Good morning, everyone, and this is lecture number 13, and we are dealing in electric current. In this class, we will go ahead and see some electrical measuring instruments and probably wind up this class here. Electrical instruments. Now, what are the electrical measuring instruments that you have heard about? You have heard about any electrical instruments? Do you know the name of any electrical instrument? Yes. What name do you know? Anyone can tell me name of any electrical instrument? Voltmeter, correct? Voltmeter, ammeter, Meterbridge, all these are electrical instruments. We will start with ammeter. What is an ammeter? What is an ammeter?
Which measures the current.
Yes, it is a device which measures the current in the circuit. It is a device which measures the current in the circuit. And remember, it is always connected in series in the circuit. Do we know this? It is always connected in series, and in whatever branch this ammeter is connected, we will get the current in that branch with this ammeter. Now, how do we denote ammeter? Gola, a round circle with a that is an ammeter. Now, whenever we talk about ammeter, there are two types of ammeter that we shall come across. The first one is known as an ideal ammeter, and the second one you can call it as the real ammeter. You can also call it non-ideal, but it is more like real ammeter. Now, what is an ideal ammeter? Now, whenever we talk about anything which is ideal, the resistance in terms of electric current, the resistance of an ideal ammeter is 0. Do we understand this?
Yes,
Here,
sir.
any electrical device, as I told you, is a resistance or a capacitance or an inductance or a combination of these two or three. Real ammeter consists of a device and the resistance is not equal to 0. An ideal ammeter, which does not exist, measures the actual value of current, but an ideal ammeter will not measure the actual value of current. There is an error in measurement because it has its own resistance. So, everyone understands an ideal ammeter and a real ammeter? Am I audible and visible to all of you? Okay. So, an ideal ammeter, the internal resistance is 0. Ammeter measures current. How do we connect an ammeter? It is connected in series. I'll give you 2 minutes so that you can note it down, and then we will solve one or two problems to understand the importance of emitters. Let me know once you are done. Let's move ahead and see this question. In this question, what I have done is I have a circuit and I have put two emitters here. In left hand side, case number 1, the emitter is ideal. That means it has no resistance. In case number 2, the emitter is not ideal. That means it has some resistance. In both the cases, you have to find out the reading in the emitter. Now, whenever I say reading in the emitter simply means the current in that branch. Do we understand this? Do we understand this? Yes or no? Am I audible
Yes,
and
sir.
visible to all of you? Okay. Reading in emitter you have to find and the percentage error. In the first case, the emitter will give you the correct value of current. In the second case, there would be an error. You have to find the percentage error. I'll give you 2 minutes to give me the answer for this one. You know how to do this? So how I'm supposed to do this? It's very simple. In first case, I can find out the current. What is the current? What is the current in the first branch? Total resistance is 5 ohms. Battery is 10 volt. You can apply Kirchhoff law. Without even apply Kirchhoff law, you can find out the value of current. 10 divided by 5, it will be 2 amperes. The current in the first circuit is 2 amperes. If I talk about the second circuit, the emitter also has a resistance 5 ohms. 5 ohms plus 5 ohms. Total resistance becomes 10 ohms. Total current becomes 10 volt divided by 10 ohms. It becomes 1 ampere. So in the original current is 2 ampere, but what your emitter will read in the second case is 1 ampere. So how do I find the percentage error? Reading minus the actual reading divided by the actual reading multiplied by 100 percentage. So you will get minus 50%. It is going to show you an error of minus 50%. It is going to show you a value which is 50% of the original value, and therefore there is always a error when you use an emitter. Do we understand this, everyone?
Yes, sir.
I'll give you 1 minute to note it down, and then we'll move on to the next question. So this is the question. Three emitters A1, A2, and A3. You have to find out the readings of emitter A1, A2, and A3. I'll give you 2 minutes to solve this. So let us find out. If I call this current as I1, if I call this current as I2, and if I call this current as I3, let us say, it's very easy to find out the value of I1. What will be the value of I1? And the value of I1 will be the reading in this pink emitter. What will be the current here? You can see that these two resistors are connected in parallel and there is nothing else. So 12 volt battery is applied across 6 ohms. So the current in this branch will be 2 amperes. Yes or no? Therefore, the reading in emitter A1 will be 2 amps. Everyone got this answer?
Yes, sir.
Then similarly, you can find out the reading in this emitter A2. 12 volt is connected across 3 ohms. So you will have 12 divided by 3. 4 ampere would be the current in this branch. Now you can apply junction law at this point. I2 and I1 are outgoing currents. I3 is the incoming current. I3 will be equal to I1 plus I2, and therefore the current in this branch, let me color it as blue. The current in this branch would be how much? 4
6
plus
amp.
2, and that would be 6 amps. Everyone understands how this is done? So basically, whenever you are having current, whenever you are having ammeter, you just have to find out the current in the different branches. Do we understand this? Yes or no? Huh? Yes or no? We everyone got this answer?
Yes, sir.
Well done, sir. That takes us to the next device, sir. And what is the name of the next device, sir? The name of the next device is voltmeter. What does a voltmeter do? It measures
Voltage.
potential difference or voltage between 2 points. Do we understand this?
Yes, sir.
What is the potential difference or voltage difference between 2 points? How is this voltmeter connected? I hope you understand that this voltmeter is connected in parallel. And how do we write this voltmeter? I write it like this. V in a gola. Everyone understands this? Yes or no? Now, whenever we talk about voltmeter, we can have two types of voltmeter. The ideal voltmeter, which obviously does not exist. There is nothing which is in this universe is ideal. And the other one would be a real voltmeter. Can anyone tell me what will be ideal voltmeter and what would be real voltmeter? Everyone can hear me, right? Yes or no?
Yes, sir.
Getting messages that I'm not audible. Okay, good. So, what is an ideal voltmeter and a real voltmeter? Remember, for an ideal voltmeter, the resistance of an ideal voltmeter, listen to me very carefully, resistance of an ideal voltmeter is infinite, very, very, very large. It has to be very, very large. It has to be very, very large so that it does not draw any current from the circuit. The resistance of this voltmeter, which is ideal, is not equal to infinite, because whatever we do, we cannot make the resistance infinite. It gives the real value of voltage. It gives us the real value of voltage. Here there is always an error because the resistance is not infinite. I'll give you 2 minutes to note this down. Once you note this down, let me know so that we can start with some questions. Well, then I bring to you this question. I'm just making this question. This is how voltmeter is connected. It is connected in parallel like this. Okay. So I have made two circuits for you. Do not feel that these are very difficult circuits. These are very simple circuits. On the left hand side circuit, what I have is an ideal voltmeter. So its resistance is infinite. Here we have a voltmeter whose resistance is given as 3 ohms, which is obviously not infinite. Now we have these two questions. Same circuit. In one circuit, I have an ideal voltmeter whose resistance is infinite. In one, it is real. You have to find out the reading in the voltmeter. Now, whenever I talk about the reading in voltmeter, it is the potential difference between these 2 points. Do we understand this? Where voltmeter is connected?
Yes,
Do,
sir.
and you have to find the percentage error. What is the percentage error that you have? I'll give you 2 minutes. Remember, voltmeter is not measuring current, it is measuring potential difference. I'll give you 2 minutes to do this. Let me do this for you and see how it is done. Now, in the first case where you have, in the first case where you have the ideal voltmeter, the resistance is infinite, so it will not draw any current. So if you find out the current in the circuit, to find out the current in the current in the circuit flows like this: ding 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 ding. No current goes in that branch where voltmeter is connected. Do we understand this? Yes or no? So
Sir.
if I have to find out this current, I can easily find out the value of this current. What will be the value of this current that is flowing? The total voltage is 2 volt and the total resistance is 8 the total voltage is 8 volt and the total resistance is 8 ohms, so the current will be 1 ampere. Do we understand this? Yes or no?
Yes, sir.
Now once you have the current as 1 ampere, you have to find the potential difference between the points A and B. How will you find the potential difference between the points A and B? I multiplied by R. Do we remember this? V is equal to IR.
Yes, sir.
So I into R, 1 amp into 6 volt, 1 amp into 6 volt, 1 amp into 6 ohms will be 6 volt. So the actual value of VAB is 6 volts. Do we understand this?
Yes, sir.
Yes or no? Okay.
Yes.
Now look in the second case what is going to happen. Current is going to come here, here. But at this point, at point A, the current is going to divide. Some current will go in this branch and some current will go in this branch. Do we understand this?
Yes, sir.
Because it now has a resistance, so current will go in this branch. Then, oh sorry. Then the current will join together and come back like this. Do we understand what I have drawn here? I, this is I. Now, how will you find out the value of this I? 6 and 3 are in parallel. Do we see this?
Yes, sir.
6 and 3 are in parallel, so that becomes 2 ohms. 2 ohms and 2 ohms are in series, that becomes 4 ohms. Total resistance becomes 4 ohms. Yes or no?
Yes, sir.
Total resistance becomes 4 ohms. Total voltage is 8 volt. So you will get the voltage, you will get the current as 2 ampere. Yes or no?
Yes, sir.
The current has become 2 ampere. Now you have to find out the potential difference between the points A and the point B. How will you find out the potential difference between the points A and B? Again, the same formula. I multiplied by the resistance between A and B. What is I? I is 2 ampere. What is the resistance between A and B? 6 and 3 are in parallel. So the resistance becomes 2. Yes or no? So the answer that you
Yes,
will
sir.
get will be 4 volt. The actual is 6 volt, but what you are getting is 4 volt now. So the percentage error will be 4 multiplied 4 minus 6 divided by 6 multiplied by
Sir, your
100
voice is
multiplied by 100. So it is
sir.
33%. Do we get this? Yes, no? Everyone is getting this.
Yes, sir.
Okay, I'll give you 2 minutes to note it down. Balance Wheatstone bridge, right up till here, and then I'll give you a diagram. So what we have seen is a balance meter bridge works on the principle of balance Wheatstone bridge. Now the diagram for this is pretty simple. It will have a battery, it will have a switch, then it will have a wire. This will be the wire, and the length of this wire is going to be how much? 100 centimeters. Do we understand this? Then you will have two resistors. One will be a known resistors, let us say R, and one will be an unknown resistance, let us say S, and then you will have a galvanometer. What is a galvanometer? A galvanometer is a device that can measure very small currents. A galvanometer is a device that can measure very small current. And then you have a jockey. Jockey is nothing but a stick, jockey. And this galvanometer is moved along this wire so that the galvanometer, so that the galvanometer has zero current in it. That is known as the null point. Do you understand? Null point. Null point means there is no current. You understand this?
Yes, sir.
Now, if the length of this segment is x, then what will be the length of the other segment where you get the null point? It will be 100 minus x. Yes or no?
Yes, sir.
This R is a known resistance and this S is an unknown resistance. You have unknown resistance on the left hand side and known resistance on the right hand side. Do we understand this?
Yes, sir.
It is a balanced Wheatstone bridge. So R divided by the resistance of this part, R divided by the resistance of this part will be equal to S divided by the resistance of this part. Do we understand this?
Yes, sir.
Now the resistance of the pink part will be proportional to X and the resistance of the blue part will be proportional to 100 minus X. We understand this?
Yes, sir.
From there we can write this equation. S divided by R will be equal to 100 minus X divided by X. Yes or no? If you know the value of
Yes,
X,
sir.
because you will be knowing the value of X, you can calculate the value of S if you know the value of R. Do we understand this?
Yes, sir.
Yes or no? No or yes?
Yes, sir.
Okay, I'll give you 1 minute to note it down. Let me know once you are done. Okay, then I have a small question for you. This is, we have not drawn the full circuit, only this part we have drawn. 6 ohm is a known resistance and we get the null point at 60 centimeters. This is a meter bridge. R is an unknown resistance. Can you tell me what will be the value of R from this meter bridge circuit? Can you do that? Yes or no?
Yes, sir.
I'll give you 2 minutes to give me the answer. So how are we supposed to get the answer? This is 60 centimeter, so we can understand how much will be this. This will be 40 centimeter, yes or no?
Yes, sir.
The balance Wheatstone bridge, so after that it is very simple. 6 divided by 60 should be equal to R divided by 40, yes or no?
Yes, sir.
From there you can find out the value of R. R will be 4 ohms. We understand this, yes or no? No, yes.
Yes, sir.
Can I give you one more question on this?
Yes, sir.
Now this is the reverse question of this. 8 ohm and 12 ohm resistance are given. This is a meter bridge, 100-meter wire. Can you find out where will I get the null point here? So can you tell me, the wire starts from point A, sorry. The wire starts from point A. Can you tell me the value of x? Where will I get the null point in this case? You understand the question, everyone?
Yes, sir.
I'll give you 2 minutes to give me the answer. Well done. So I think you have an answer. If this is x, so whatever is left will be known as 100 minus x. Yes or no?
Yes, sir.
So I can simply write here, bacha, 8 divided by x will be equal to 12 divided by 100 minus x. Yes or no? This is 2,
Yes.
this is 3. So from there you can get the value of x. What are you getting? 40?
Yes, sir.
X will be 40 centimeters. Done and dusted. Everyone has understood what we have done.
Yes, sir.
Everyone in the class, I am not hearing any other voices. Am I audible and visible? Yes or no?
Yes, sir.
Okay, everyone has understood what we have done.
Yes, sir.
Today's class, we have seen the electrical instruments, we have seen ammeter, we have seen voltmeter, and we have seen meter bridge. It brings us to an end of this session and this topic. In the next class, we will be starting with magnetic effects of current. So be prepared. In the next class, we are starting the next topic, magnetic effects of current. And I hope that we will be completing it very soon. So bye bye from my end. The class for this session is dismissed. If you have any doubts, you can ask them. Anything that you want to ask. The class is over. Take care. God bless you all.